Now we learn about what is the method 5. If the equation is in the form x to the power a multiplied by y to the power b bracket py dx plus qx dy plus x to the power c multiplied by y to the power d plus my dx plus nx dy is equal to 0, where a b c d p q m n are constants. Here integrating factor is x to the power h y to the power k, where h and k are obtained by apply the condition del m by del y is equal to del n by del x after multiplication by x to the power h multiplied by y to the power k in the given equation to be exact. Here we can see if the given differential equation m dx plus n dy is equal to 0 is not exact, then we check the given equation is in the form x to the power a multiplied by y to the power b bracket py dx plus qx dy plus x to the power c multiplied by y to the power d bracket my dx plus nx dy is equal to 0, where a b c d p q m n are constant. Then integrating factor, we suppose integrating factor is x to the power h and y to the power k. Then we multiply the given differential equation by x to the power h, y to the power k, and obtained value of h and k by applying the condition del m by del y is equal to del n by del x after multiplication by x to the power h, y to the power k in the given equation to be exact. Now we take some question on this method. So the question is here 2y dx plus 3x dy plus 2xy 3y dx plus 4x dy is equal to 0. We can see here this equation can be written as x to the power 0 y to the power 0 2y dx plus 3x dy plus here we can see this is x to the power 1 y to the power 1 and 6y dx plus 8x dy is equal to 0. So this is in the form x to the power a multiplied by y to the power b bracket py dx plus qx dy plus x to the power c multiplied by y to the power d bracket my dx plus nx dy is equal to 0. We can see this is the equation of the form x to the power a multiplied by y to the power b py dx plus qx dy plus x to the power 1 y to the power 1 x to the power c y to the power d and m y dx plus nx dy is equal to 0. We can check the given differential equation is in the form x to the power a multiplied by y to the power b bracket py dx plus qx dy plus x to the power c multiplied by y to the power d bracket my dx plus nx dy is equal to 0. Here value of a is 0, b is 0, p is 2 here, and value of q is 3 here, and value of c is 1 here, value of d is 1, value of m is 6, and value of n is 8. So first we check here the given differential equation can be written as 2y plus 6xy square dx. We take the terms uh, in one bracket which multiply with dx, and now we take those terms which are the coefficient of dy in one bracket. So here 3x plus 8x square y and dy is equal to 0. Here we take the coefficient of dx in one bracket. So here the coefficient of dx is 2y, here the coefficient of dx is 6xy square. So we take first bracket 2y plus 6xy square dx. In the second bracket we take coefficient of dy, that is 3x here, and here the coefficient of dy is 2 4 8x square y. Now we check here, compare by m dx plus n dy is equal to 0. So coefficient of dx is m here, m is 2y plus 6xy square, and coefficient of dy is n here, so n is 3x plus 8x square y. Now we differentiate m partially with respect to y. So this differentiation of 2y with respect to y, partially we get 2 and differentiation of y is 1. Here when we differentiate 6xy square, so 6x is constant and differentiation of y square with respect to y, this is 2y. So this becomes 2 plus 12xy. We can see here this is del m by del y equal to 2 plus 12xy. Now we differentiate n partially with respect to x. When we differentiate 3x, so 3 is constant and differentiation of x with respect to x, this is 1. And here 8y is constant and differentiation of x square with respect to x, this is 2x. So this can be written as 3 plus 16xy. So this is del n by del x. We can see here del m by del y is not equal to del n by del x. So the given equation is not exact. Here the given equation is not exact, but we can see that this is the given differential equation can be written in the form x to the power a multiplied by y to the power b bracket p y ds plus q s dy plus x to the power c multiplied by y to the power d bracket m by dx plus n x dy is equal to 0. So we apply here method 5. So we suppose that integrating factor is x to the power h multiplied by y to the power k. Here we suppose that integrating factor is x to the power h multiplied by y to the power k. So integrating factor is x to the power h y to the power k. Now we multiply this integrating factor in the given equation. So this can be written as 2x to the power h multiplied by y to the power k plus 1 plus 6x to the power h plus 1 y to the power k plus 2 dx. In the second bracket we multiply x to the power h y to the power k. So this can be written as 3x to the power h plus 1 multiplied by y to the power k plus 8x to the power h plus 2 multiplied by y to the power k plus 1 dy is equal to 0. In the above equation m dx plus n dy is equal to 0, we multiply the integrating factor x to the power h multiplied by y to the power k. We know that if we multiply the integrating factor, the given equation will be exact. So here we apply the condition, since when we multiply the integrating factor above equation is exact. So apply del m by del y is equal to del n by del f. Here m is this and n is this here. So we differentiate m partially with respect to y. So when we differentiate this 2h to the power h y to the power k plus 1 with respect to y, so this 2h to the power h is constant, and differentiation of y to the power k plus 1 with respect to y, so this is k plus 1 y to the power k plus, here we differentiate 6x to the power h plus 1 y to the power k plus 2, so 6 here and h to the power h plus 1, this is constant because we differentiate m partially with respect to y. Now we differentiate y to the power k plus 2, we get here k plus 2 and y to the power k plus 1. Similarly, we differentiate n partially with respect to x. So when we differentiate this term with respect to x, so 3y to the power k, this is constant, and when we differentiate x to the power h plus 1, we get h plus 1 x to the power h. Similarly, the second term 8 is constant here, and when we differentiate x to the power h plus 2, so here h plus 2 x to the power h plus 1 and y to the power k plus 1. Now we equating the same power of x and y, coefficient of same power of x and y. Here the coefficient of x to the power h multiplied by y to the power k is 2 times k plus 1. In the right hand side, coefficient of x to the power h multiplied by y to the power k is 3 times h plus 1. So 2 times k plus 1 is equal to 3 times h plus 1. We solve this to 2k plus 2 is equal to 3h plus 3. So we write here 2k is equal to 3h plus 1. So here, from here we write k is equal to 3h plus 1 divided by 2. Now we equate coefficient of h to the power h plus 1 multiplied by y to the power k plus 1 in both the sides. So the coefficient is here 6 times k plus 2. In the right, coefficient is 8 times h plus 2. So we multiply 6k, this is 12, and here 8h plus 8 to just 16. So 6k is equal to 8h plus 16 minus 12, this is 4. Now we divide this equation by 2, we get 3k is equal to 4h plus 2. Now we put here value of k, 3h plus 1 upon 2, so this is 3h plus 1 upon 2 is equal to 4h plus 2. Now this can be written as 9h plus 3 is equal to 8h plus 4. So here 9h minus 8h is equal to 4 minus 3, 1. So h is equal to 1 here. Put value of h in this, we get here 3 plus 1 upon 2, this is 4 upon 2, so k is 2 here. So we can see here h is equal to 1 and k is equal to 2. Now we put value of h and k in above equation A. We put value of h and k in above equation A. So we write here 2x, in place of h we put here 1, in place of k we put here 2, so this is 3 plus 6x to the power 2 and y to the power 4 dx, plus here we put 3x to the power 2 y to the power 2 plus 8x to the power 2 plus 1 plus 2, this is 3, and y to the power 2 plus 1 3, or dy is equal to 0. Here we put value of h and k in the above equation A. In place of h we put here 1, in place of k we put here 2, so this is 2xy cube. In the second term we put in place of h we put 1, so 1 plus 1 2, so this is 6x square. In place of k we put here 2, so y to the power 2 plus 2, that is y to the power 4 dx. In the second bracket we replace h by 1, so we get 3x square and k by 2 y square plus 8 x to the power h plus 2, so h is 1 plus 2, this is 3, and y to the power k plus 1, so k is 2 here, so y to the power 2 plus 1, that is 3. Now we know if the integrating factor is multiplied in the given equation, it reduces to the exact form. So this equation is in the form exact. This equation is exact. Now we write here solution, and we know that solution is integration of m dx plus n1 dy is equal to c1. We know that n1 is obtained from n, and we take those terms of n in which x is absent. But here in both the terms of n there is x, so value of n1 is 0 here, and value of m is here 2xy cube plus 6x square y to the power 4 dx is equal to c1. Now we integrate here x with respect to x because 2y cube is constant, so integration of x is x square by 2, so 2 is cancelled out, so this can be written as x square y cube plus, here we integrate this x square with respect to x, so we get here s cube by 3, so 3 cancelled by 6, so this is 2, 3 to the 6, 2s cube y to the power 4 is equal to c1. So this is the solution of the given differential equation x square y cube plus 2x cube y to the power 4 equal to c1. Thank you.